Welcome back to All This Math. This is your host, Professor Parker. And on today's lesson, we're going to talk about mixture word problems. Mixture word problems. And as you can see on my chest, we have a young W.E.B. Du Bois, William Edward Burghardt Du Bois. Please do your reading on Du Bois. Familiarize yourself with him. Read some of the work that he wrote himself. All right, that's my recommendation to you. Read his autobiography. Also read some of the biographies that have been written about him by authors such as David Levering Lewis. Read some of his other works like The Souls of Black Folk. You got to be ready for that. That's kind of dense. You got to really take your time with Souls of Black Folk. Dark Water. Dark Water is a good one. A lot of solid essays in Dark Water. Similar to Souls of Black Folk. What else we got? We got The Negro. There's a compilation of essays about education called The Education of Black People. And just a lot. It's a lot of and actually there's like another compendium, I guess it's called a compendium, called an ABC of Color. An ABC of Color, which is another compilation of some of Du Bois' essays. But please educate yourself on a lot of his theories, a lot of his ideas. The brother was born in 1868. He didn't transition until 1963, actually a day before the historic March on Washington in 1963. So he lived a long life. He provided a lot of analysis on conditions in America and just in the world in general, and the condition of Black people and people of African descent. So please do familiarize yourself with Du Bois. Learn about his work. Learn about some of the things he was right about. Learn about some of the things he was wrong about, and he later corrected himself on. So definitely check out his work. All right. Now, on to this problem. Now, this is a word problem that we're working on. And as you see, I don't have the word problem written down on the board because I didn't want to take up space with that. But you can see the entire word problem in the description below this video. So the word problem is available. So, you may want to copy it down onto your paper and hit pause right now and copy the word problem down on your paper so you can follow along, and then hit start again. All right. But I'm going to read it. All right. Because that's the first thing we got to do. Before we do math, we got to know how to read. And we got to also know how to comprehend. We got to read and comprehend. We got to get out of this false dichotomy that you can be either a math person or a reading person. You can't be a math person if you can't read. Straight like that. You can't be a math person, a so-called math person, if that's even a thing. You can't be a math person if you can't read. All right? You know what I mean? You got to be able to read word problems, comprehend word problems, and then understand how to translate that word problem written in whatever language it's written in, whether it's English, Swahili, whatever, into an equation, and then solve that equation, and then start doing the math. All right, but you got to read first. So anyway, the problem goes like this: how many gallons? So picture a gallon, right? Like a gallon of milk. I hope you're not drinking cow's milk, but that's your business, right? But anyway, how many gallons of a 10% salt solution? 10% salt solution must be mixed with 12 gallons of a 15% salt solution to obtain a 12% salt solution, right? Now, one of my recommendations to students all the time is when you encounter word problems, read them at least 3 times. At least 3 times. We just read it once. Let's go in again. How many gallons of a 10% salt solution? And I say that because every time you read it, the problem's going to start to make a little more sense. It's going to be a little more, familiar. You'll be able to understand it a little bit better every time you read it. How many gallons of a 10% salt solution must be mixed with 12 gallons of a 15% salt solution? So notice how the second mixture, they tell you how much it is, 12 gallons of it, right? And the concentration is 15%. So, think about when you're making iced tea, right? There's this ongoing thing between my sisters and my mom about who makes the best iced tea. Is the iced tea sweet enough when we have little family gatherings? Some people like the iced tea real sweet, and then you gotta cut it, put the ice in your cup before you pour it because it's gonna be sugary, real extra sweet. Some people don't like it that sweet. A lot of people are like that, right? So when you think about a mixture like this, think of making iced tea, or think of making Kool-Aid if you drink Kool-Aid, or any type of mixture, right? And this is a liquid, right? This solution is a liquid. And we want to obtain a 12% salt solution. So we got a mixture, right? But we don't know how many gallons it is, right? That's what we're trying to figure out. How many gallons of a 10% salt solution? But let me talk about that. What does a 10% salt solution even mean? What does that even mean? I shouldn't take that for granted. A 10% salt solution means that, and you got to understand something about percentages, knowing that the entire amount is 100%, right? Of anything. The entire amount is 100%. So if it's a 10% salt solution, that means a fraction of that, or 1/10 of that, or 10% of that is salt. The other 90% is other stuff. Other 90% might be water, might be some other chemicals, whatever. But 10% of it is going to be salt, right? That's why it's called a salt solution. It's a mixture. A solution is a mixture, all right? 10% of that is straight salt, all right? Sodium, okay? Then the other one, the other mixture is 15% salt solution, meaning 15% of that is straight salt. 100 minus 15 is 85. So the rest of it, the other 85%, is other stuff. Could be water, chemicals, whatever, right? We don't really care about that. That's not really relevant to this problem, but I just wanted to give you that background so you understand the concept of what a solution really is. All right, now you know how much of the second mixture or solution you have. You got 12 gallons of it. And we want to obtain or end up with a 12% salt solution. Now, somehow they don't tell us how much we're going to end up with of the 12% salt solution. But we can think to ourselves, well, if I'm mixing a certain amount of gallons with 12 gallons, right, then it's going to be a total of those amount of gallons added together, right? So let me do this. Let me give you like a general formula that you can follow whenever you see a problem that looks like this, all right? So what we're doing is we kind of doing this. Now the 10% salt solution, we'll call that a concentration. A concentration. How much of the salt, how much of the item is concentrated in the solution, right? So we're gonna have, let's say, quantity times concentration plus quantity times concentration is equal to quantity, notice a pattern here, times concentration. I'm gonna just say CONC as an abbreviation for concentration. So I got quantity times concentration plus quantity times concentration. So this is my first mixture. This is my second mixture added together. When you add them together, your total is gonna be equal to what we obtain, a quantity times concentration. So that's how we got set up the equation. So whenever you see a problem like this, just know that you can use this setup, right? Use this setup. Quantity times concentration plus quantity times concentration equals quantity times concentration. Now your job is to go back into the word problem, pull out the information, and replace as many words as you can with numbers. So read the problem again. How many gallons of a 10% salt solution? That's the first mixture they talk about. How many gallons? How many gallons is the quantity? They don't tell us the quantity. They don't tell us how many gallons. That's our job. We got to figure that out. We're problem solving now. We got to figure that out. So that means we got to replace quantity, but not with a number, because we don't know what the number is. That's why we have algebra as a tool, so we can figure things out. And if we can figure it out in a problem like this, we can figure out problems in life. That's the purpose of learning math. So you can learn problem solving skills. So many people have no problem solving skills. So their problems just persist. If you have problem solving skills, it don't mean that you're always going to come up with the correct solutions to your problems, but you'll be in a better position to come up with correct solutions to your problems. So keep that in mind when you be sitting in class thinking, why I got to learn this? Why I got to do this? It's so you can develop problem solving skills, because we're human beings and we all will encounter problems inevitably. All right. So we don't know what the quantity is. So let's call that X. So I'm going to say X, and then the concentration is 10%. Now, how do I represent 10%? I'm going to represent 10% as a decimal. I'm going to call it 0.10. So X times 0.10. Now, this is not a multiplication sign. It's a variable X. All right. I could have used Q for quantity. You use any variable you want. It don't matter. Right. I usually use X. So, and I use 0.10 because it's a 10% solution. And that's the concentration, the amount of salt that's in the solution. Then I put a plus sign. Then my quantity in my second mixture is 12 gallons. 12 gallons. All right. So now I know the quantity in the second mixture. In the first mixture, I didn't know the quantity. I ain't know it. But in the second mixture, I know it. So I got 12, right? And what am I going to multiply that by? The concentration in the second mixture. The second mixture is 15%. 15%. So I'm going to represent that as a decimal, take it out of percent format, and represent it as a number, 0.15. 15% is the equivalent to 0.15. Make sure you know that. Just like 10% is equivalent to 0.10. Now, somebody might just write 0.1. And if they do that, that's fine too. This zero is really superfluous. Superfluous, the word for the day, superfluous, meaning it's extra. You don't really need it, right? So this could be 0.1, but I just wanted to, since I was dealing with 10% and the zero was already there, I just figured, just throw it in there. It ain't hurt nobody, right? So 0.10. All right, now the equal sign. When the equal sign comes down, now that's equal to a quantity times a concentration. Now, we want to obtain a 12% salt solution. So ask yourself, what will my quantity be? The quantity is going to be the sum of the two quantities that you're already combining. This quantity is X. This quantity is 12. So you might be wondering, well, how am I combine that? That's not a number. It's okay. You can represent it as an expression that represents the fact that you're trying to combine those two quantities. So watch this. This is what you do. You draw parentheses and you do X plus 12. X plus 12 is your quantity that you're going to end up with, because it's this much plus this much. This much plus this much. That's what you're doing. You're mixing this much with this much. And then you gotta account for the concentrations, right? It's like a chemistry problem for real, right? So then the concentration is gonna be 12%, right? So I'm gonna convert that out of percent form and I'm gonna write 0.12, right? Because that's the concentration we wanna end up with. So this is how we get into like my sister, right? Making the iced tea. You got to pour a certain amount, you got to mix a certain amount of water with a certain amount of iced tea mix to get the flavor just how you like it. So understand, whenever you making beverages, whenever you mixing things, if you're a child watching this, if your parents are mixing drinks at the gathering or whatever, they got to mix it a certain way. So, whatever, they're doing chemistry. They're doing chemistry. That's what's happening. We're doing chemistry. And if we want to end up with a mixture that's 12%, we got to make sure we mix a certain amount of the different mixtures together in a certain way. So if we want to end up with a 12% mix, we got to figure out, okay, well, how much of the 10% mix do I need to combine with the 15% mix? Because I don't want this to be too salty, but I don't want it to not be salty enough, right? So now we got our equation set up. And once we got our equation set up, now we can start getting into the algebra now, right? So look what we did. We read the problem, we read it again, then we read it again. We tried to understand what was written in the problem, and then we started out with a general equation. A general equation. Quantity times concentration plus quantity times concentration equals quantity times concentration, right? So that lets you know whenever you see a problem that looks like this is the setup, right? This is the setup. Just like when you're playing video games, right? If you're playing Madden or you're playing 2K, right? You see a certain defense, you see a certain offense. You might have so much experience with that game that you know what's about to happen. So when you see certain word problems, you got to be like, oh, okay, I know what this is. You see something that look like this word problem, here go your setup right here. It's the same thing. It's like playing a video game. That's all it is, right? So now we're going to combine these. I'm going to clean this up because really the number should go in front as a coefficient. So this is going to become 0.10x plus 12 times 0.15. So I'm going to do 12 times 15. Actually, I'm going to flip it. I'm going to do 15 times 12 because multiplication is commutative. The order don't matter, right? When you do multiplication. 15 times 12, I'm going to break it down and use distributive property. I'm going to break 12 down into 10 plus 2. 10 plus 2, because then I could do 15 times 10, and I could do 15 times 2 and add them together. 15 times 10 is 150. 15 times 2 is 30. 150 plus 30 is 180. But this has 2 decimal points in it, or this has numbers. This is rounded to 2 decimal places, I should say. So that means instead of 180, it's going to be 1.8. So this is 1.8, right? 1.8. And think about it. If you had 15 cents, 0.15 is equivalent to 15 cents. So if you had 15 cents 12 times, that's $1.80. That makes sense. That sounds reasonable. All right, then we go here, again, distributive property again. X times 0.12 is 0.12x. 12 times 0.12 is 1.44, because this is like 12 cents 12 times, or 12 times 12. Make sure you know your multiplication facts, at least up to 12 times 12, 144. Back of your composition book, right? 12 times 12 is 144, and then there should be 2 digits after the decimal point, because this had 2 digits after the decimal point. This didn't have no digits after the decimal point. So in all, you should have 2 digits after your decimal point. So that's gonna be 1.44, right? So now, this is your equation. So now I got x's on the right side, I got x's on the left side. That's a problem. I need to fix that. So watch, I'm about to clean this problem up. I want all my x's on the left side, and I want my constants on the right side. Now, it's a few ways to do this, but the way I'm gonna use is called transposing, where we basically just pick the numbers up and just move them. Basically. So watch this. Now it's gonna look like this. 0.10x minus 0.12x. Whenever you transpose, you have to change the sign of the term that you move to the other side of the equal sign. So this used to be a 0.12x on the right side. Now I move it to the left. Now it's minus or negative. All right. So now it's equal to negative 1.8. Now, does it matter if I put the 1.8 in front or after the 1.44? No, it does not matter, in case you was wondering. All right. And then we got plus 1.44. The 1.44 was already over there, so that sign don't change. Just like the 0.10x was already over there, so that sign don't change. Now, what was the purpose of me doing this, though? The purpose of me doing this is so that we can combine like terms. Now we got, because you can't combine like terms when you got an x on the left and an x on the right. You can't combine these. You can't combine them until they're on the same side of the equal sign. So now we got 0.10 minus 0.12, which is going to be negative 0 or negative 0.02x, because that's like 10 cents minus 12 cents. 10 cents minus 12 cents is negative 2 cents, or 2 pennies. Like you owe somebody 2 pennies, something like that, right? And then we got negative 1.8 plus 144. That's like negative $1.80 plus $1.44. That's going to be negative 36 cents. Or negative 0.36. Now I'm about to be done. I'm trying to get this x by itself. So I got to get rid of this negative 0.02. I do division. Negative 0.02 on the left. And also we got to stay balanced, like ancient Kemet, Mayat, all that. Balance. Math teaches us balance. If I do something on the left-hand side, I got to also do it on the right-hand side. That's how I stay balanced. Divide by negative 0.02, excuse me. So these cancel out. Now we got x is equal to, and negative 0.36 divided by 0.02 is going to be 18. So if x is 18, that means that that's my quantity. So that's how many gallons. That's a lot. I need 18 gallons in order to end up with, so basically it's like this. If I want to end up with a 12% salt solution, right? I got some 10%, because this is what happens, right? Like let's say you need a 12% salt solution, but you couldn't buy a 12% salt solution, right? Let's say, like, I don't know, if you're working in a chemistry lab or something, or a college or a high school, and you need a 12% salt solution for something, some project, some activity, some experiment, and you can't buy that wholesale, but you can buy a 10% solution and 15% solution. So then you figure out, like, all right, well, all is not lost. I can do some math and I can figure out how to make a 12% salt solution by combining them and mixing them in a certain way. But I want to end up with a 12%, so I got to do the math right. Because if I don't do the math right and I got too much salt, the experiment is ruined. If I don't do the math right and I don't have enough salt, the experiment is ruined. That's why we need to know how to do math, because of situations like that. That's real life. Those are real life situations. And if you don't know how to do the algebra to figure them things out, you just out of luck. You just gambling. You just guessing. And why leave it up to chance? You could leave it up to chance and try to eyeball it or whatever you try to do, but why not just use the math and come out with an exact amount? Because based on the numbers, right? And men lie, women lie, numbers don't, right? But the numbers ain't gonna lie to you, right? We trust the math, follow the steps. You need 18 gallons. So 18 gallons of this concentration, right? Plus 12 gallons of this concentration is going to be equal to 30 gallons, because 18 plus 12 is 30. It's going to be equal to 30 gallons. It's going to give you 30 gallons of a 12% concentration. You know? All right. Yeah. So that's how you do a problem like this. Once you see a chemical concentration or chemical solution problem like that, where you got mixtures and different amounts, that's what you got to get into. Follow this formula and then look in the word problem, figure out what's in there, and set up your equation using the information from the word problem, and then just go to work. All right. Now, go get some practice. Practice more of these problems. Use this video as a guide. Ask your teacher, ask your professor, whoever, whether it's your algebra professor, whether it's your chemistry professor, whoever, right? Ask for more practice problems for you to work on. Ask for more practice problems for you to work on. Work on them so you can master this skill. So that way, whenever you see a problem that look like this, you don't got to get intimidated. You'll be like, oh, I know how to do this because I practiced. All right? So go get some practice, and I'll see you in the next video. Peace.